Morning, everyone.
Good morning.
I'm glad to see so many people here on a Saturday morning, and so many other good things to do, but I'm excited you're here with me. I want to quickly get a show of hands for Enigma people abstain. How many people had you heard about Enigma before coming to the hackathon or learning anything about ETHBoston? Okay. So this talk is really packed, but I don't expect that you're going to follow along 100%. But rather, I want to give you an overall sense of what it might be, what it would look like to be hacking on Enigma. So I'll be showing this slide at the beginning, in the middle, at the end. You can, you have time to go through this. There are 1, 2, 3, 4, 5, 6 or 7 of us around, so there's plenty of people to talk to. I'll highlight them at the end. So I'm more interested in keeping up with big picture. So and research shows that people will get at most 3 ideas from any given talk. So I'm going to focus on trying to hammer 3 ideas. The first one being, if you think about Enigma, think about the privacy layer for Ethereum. And so let's talk a little bit about the problem of privacy. Data on the blockchain is public by default. I mean, that's the whole thing where I'm promised about the public ledger and being auditable and whatnot. But this greatly limits the potential application. Think about all the services that you interact with, or that you benefit, or that you use in your regular life, and the fact that that information, there's some information there that you don't want to put in the public blockchain, and you don't think from health records, your final information, your employment history, your salary, your friends, your contacts, and yada yada, to more mundane things like you're playing a game, say a strategy game, and the moment that you reveal your strategy, game is over. So you can think about privacy in very important terms, but also in rather trivial terms that allow for interesting things to happen. So Enigma solved precisely that problem, where we enable decentralized applications to compute over encrypted data. And you should think about Enigma as a layer 2 solution, where Enigma is the computation layer, and we use Ethereum as the verification layer or the consensus layer. We use Ethereum as the source of truth, which allows for great scalability too, because you can offload all the computation to this other network and just use Ethereum for coming to a consensus. So Enigma Discovery is the first network that publicly enables, we call it secret contracts, as analogy to smart contracts, where secret contracts you can encrypt over, you can compute over encrypted data, and you have permissionless network. It's economically incentivized in a similar way to proof of stake, and most relevant to this talk and to this event is compatible with Ethereum. And one way of understanding Enigma network is to talk from the point of view of the different stakeholders involved. So, like Ethereum, we have developers who develop and deploy decentralized apps on Enigma. We have users who create tasks to use those dApps. And we have workers who execute those tasks. Workers being the analogy to the nodes on Ethereum. We use somewhat of a different nomenclature or naming or taxonomy so as not to get confused, because we are going from one network to the other all the time. So let's quickly go over the flow of how Enigma works. So developers write secret contracts, compile them to bytecode, and then deploy those contracts to the Enigma network. And those contracts are also registered on a smart contract on the Ethereum blockchain, again, to because that's our source of truth, so we have to have a record of those contracts over there. So then users interact with these dApps by submitting encrypted data. These create tasks. A hash of that task, again, is recorded on Ethereum, and the task is sent to the Enigma network. Workers receive tasks based on a stake-weighted lottery, so the more you stake, the more chances you are that you'll be chosen for a given task. Selected worker executes the task and disseminates the results back to the network. And there's an option here for when, with the result of that task, you can call something on Ethereum and act on Ethereum, hence also the interoperability with Ethereum, which we think is a critical component of Enigma. And now I'll start, so I'm hammering in this idea of privacy in Ethereum, think about Enigma. So now I'm getting into the hackathon mode where it's like, okay, you have some ideas, you need some privacy in your application. And the beautiful thing is that we are not asking you to rewrite all your application on Enigma. It's almost the opposite. You have your dApp, you have your smart contract, you can have all the business logic in your smart contract, but wait, there's that one function, there's one thing where I need to handle some sensitive data. That's where you call Enigma, Enigma calls you back. So everything else works on Ethereum, but then you can offload the sensitive information to Enigma fairly seamlessly. So the blue boxes are the elements that you as a hacker start to think of, okay, I want to use Enigma, what do I need, what do I have to use? Encrypted inputs, so whatever you send into the network, it's going to be encrypted. And we have, and I'll talk about this, we have an Enigma, we have a JavaScript library like Web3's Ethereum that basically handles all those things to you. You basically say, send task, and these are the parameters, and we handle the encryption and everything. So encrypted inputs, there's an encrypted state that can be maintained on the network and that no one can have access, that no one can read. And there's an encrypted output as a result, and then there's an Ethereum callback, as I mentioned. Okay, so fairly straightforward, inputs, outputs, and the state. Again, I'm going to be back and forth between these two slides. So let's think about where can you build on Enigma? And this is more of a brainstorming ideas, or like, at this point, your head should start spinning and like, oh yeah, I have this idea, I was missing this component, and what can I do? So type of things that you can build on Enigma, games that require you to hide actions on Ethereum, say rock, paper, scissors. It is impossible to play rock, paper, scissors on Ethereum because, you know, I commit scissors, it's like, oh, okay, I'll hit you with a rock. Then where's the fun? But now imagine that I play my game, I send my encrypted scissors to the network, you send your encrypted whatever to the network, and then the network de-encrypts the two plays and sends back the output. Or same with battleships, right? We all played the Matrix with ships on the Matrix B1, hit, 3, C4, hit, miss. That matrix of where your ships are is the state. And the B4s and C3s and B1s are the inputs that you send encrypted to the network. Similar hangman, where your actual word is the encrypted state, and you send the letters, and you can tell whether you hit or not. Scavenger hunt with secret locations. Say I tell you, go across the street on this path, and when you're at the bar, turn around and you see something. And then you say, oh, I saw a mural. So send mural encrypted to the network, and then you say, okay, now, then you decrypt the next phase, which is go across the street into the store, second aisle, what book do you see, that type of thing. And secret messaging, I think subscriptions is the easier way to get it, where you send a payment to the network, we whitelist your message sender address, and then when you want to get some information that is stored in the encrypted state, if message sender is whitelisted, then we send you the content. Otherwise, you don't have access. Okay, so we have a developer environment, much like Truffle. And I'm gonna try to keep on with this analogy all the time because really, we took Truffle, all the source code, and then we inserted a bunch of things to run, to compile and migrate secret contracts in parallel to compiling and migrating smart contracts. So if you ever use Truffle to compile, migrate, and test smart contracts, then we'll basically do the same with secret contracts. And in many slides there will be this thing where if you might be able to follow along. Again, I think this is too fast. We did this presentation in another conference where there was a bit more time. But, so if you downloaded that VM, you can go to this folder and you start the network just by running discovery start. And this runs a Dockerized network in your local host where you have an instance of Ganache that simulates Ethereum, and then you have 2 or 3 nodes that form the Enigma network where you send hash, they run encrypted, and yada, yada, yada. So this is a sample output of color by each component, brings their output and helps you figure out what's going on. So this is mostly for debugging and developing. So what I want to do today is basically 2 things, like 2 easy steps. Get introduced to Enigma in 2 easy steps. Develop a contract, interact with the contract. It's not as easy as it seems, but. And here's, I guess, the bad news for you is that secret contracts have to be written in Rust. And you say, boy, another language I have to learn. Yeah. No, I know, there's no way around it. And of course, you want to think that we picked our language for writing secret contracts, not because it was easy to use in a hackathon, but boy, it was a robust language that is memory safe, that has good performance, but essentially will preserve the privacy that we assure that the network will give you. So I thought about this talk as like, okay, I know learning a new language is Rust. It's almost impossible to do in 36 hours. But you all know some programming language, and I'm just going to hack our way through writing a contract in Rust. I don't expect that anyone will master Rust in a day. I haven't. I actually haven't even in 6 months. But at least I'll give you a way on how you can run a secret contract in less than an hour or so. And then we have 2 developers here that we can help you in writing your own. But Rust has been voted the most loved program language in 3 years in a row. So join the community, join the love. Okay, I'm a great believer in learning by doing, so I'm just going to go through the one very specific problem, which is the millionaire's problem. Some of you might be familiar with it, but it's really simple. Alice and Bob are millionaires, and they are obsessed with who is richer, as well as not disclosing their net wealth, the net worth. So they want to compare their wealth without neither of one disclosing to the other what is their worth. So it works something like this. I create a new millionaire's problem. I have an instance of the millionaire's problem. I add a millionaire, say Bob, $1 million. I add a second millionaire, Alice, $2 million. And then I compute the riches, and the result should be Alice. Okay? So basically, there's one secret contract. There are 2 functions, add millionaire and compute, and there are 2 inputs and 1 output. As simple as it gets. I'll skip this. No one is following this. this is my hack number 1. This is our organizational repo. This is one of our repos, examples, WASM contracts. There's a bunch of contracts that we have written in Rust that we have, I think, done a good job of inline documenting. So I bet that and then there's one that is really simple, but basically you have 5 or 6 contracts where we basically pretty much do whatever is possible in secret contracts. So you can just go there and copy paste. So I'm gonna go here, and this is this file, and I'm just gonna go break it down by line by line. And this file has about, there's one example, secret contract has 80 lines of code. Half of them are common, so we're down to 40. I claim that you only need to write 10 of those 40 lines. So can you write 10 lines in an hour? I think you can. So quickly, just to get you a sense of what Rust is like, and it's fairly similar to C and some Java or TypeScript. So this type of things is like copy-paste. If you don't want to understand what they do, I don't care. Just copy-paste. All the secret contracts have these lines at the top, and they get you set up. So Rust has a lot of standard libraries that the execution engine does not support. Execution engine, think about EVM, the Ethereum Virtual Machine. There's a lot of things that you cannot do in the Ethereum Virtual Machine, so you cannot do in the Enigma Virtual Machine. And so all the standard Rust functionality does not apply. So we cross out all the standard functionality. Then we bring 2 packages into scope, 1 and 2, and this one is the one that allows us to interact with the Enigma runtime, which allows us to write and read from the state and print for debugging purposes. So basically we import it, and we want to use everything that's in this package. Okay. And then there's this other package which allows us to define the functions that we can call from the smart contract and write the Ethereum callbacks. Fine, I'll import it, and I want to use all the public interfaces that this package provides. And this allows us to serialize and deserialize inputs into the contract of some custom struct types. Like, okay, all this comes for free. You just copy paste. Cool. Then the Enigma state is a hash map, and I need a key to access that hash map. So that's a string that is called millionaires. Okay. Okay. Now I'll stop here for a moment. This is where I define my data structure for the Enigma state. So it's a structure, and I have 2 fields, address and net worth, where the first one holds byte 32 hash map, interacting like an Ethereum address that is 20 bytes. And then an unsigned integer of, again, also 32 bytes. And then you say, oh, how do I come up with these numbers? Here at the end, there's the relationship between the Rust types and the Solidity types. So if you know Solidity types, you just have a one-to-one.
I wouldn't say that.
And then these are the public functions that I want to define to interact with my contract. You remember in the scheme I said there are essentially 2 functions, add a millionaire and then compute riches. And and like every programming languages, you define your inputs, this has no output, and this one has no inputs and outputs the hash of the address or the identifier of the millionaire. So then I define my contract, and I can have private functions and public functions. So this is just an example of I want to read from the state. So I want to get millionaires. So I'm going to read from the state with my key that I use to get to access the hash map, and then this will get me a vector of those structures or the empty vector. Again, you might say, well, the actual language is a little bit weird. It's like, yeah, fine, but you have a lot of examples on how to do the most basic and essential stuff. And then these are the public functions for the contract, where it's add a millionaire. So I read all the millionaires that I have already in the state, and if it's the first one, I'll get an empty vector. And so I push the inputs that I got, and I write to the state. So this is the core. Like this is the core of your contract. I want to add a million. These are like 1, 2, 3, 4, 5 lines. Can you write 5 lines? Yeah. And then compute reaches. So this is basically one line where I want to get a match, and this is like typical Rust stuff, where I want to get a match for the get millionaires, the function we saw before. I'm going to iterate through all the results. I will find the maximum by key, which is net worth of the vector that I get at. And either I'll get an empty vector if I try to call this too soon, or I'll get basically a result, and from the result I'll get this field, which is what I'll return. It's like, it's everything like sort of compressed. But again, talk to us. We know some Rust. We can help you with this cryptographic way of programming. Whew, that was it. So first idea, privacy layer in Ethereum, think about Enigma. Second idea, secret contracts are written in Rust. And there's no way around it, because it's a very good choice of a language for many other reasons. So now I have this secret contract that I've written, and what do I do with it? Much like truffle compile, I'll run discovery compile. So basically that will turn that secret contract written in Rust into WebAssembly, which is similar to the bytecode that runs on the Ethereum virtual machine. So I'll end up with a WASM file somewhere on my drive, and then, much like we do truffle migrate, we'll do discovery migrate. And that basically, we have this, we are using the truffle migration files to migrate the Enigma contracts. And all what you need to know is deploy secret contract. And you pass a file name, this is the constructor, and the amount of gas that I want to use to deploy the contract. From account 1, these are the Ganache truffle accounts. Running out of time. I want to skip that in the interest of finishing on time and being respectful with the other speakers. But basically, we have an Enigma JavaScript library, again, much like Web3 library, where you have these functions to your disposal: compute task, resolve, or find the status of the task that's been sent to the network. Okay. So I just want to finish by, so 3 ideas. The third idea being that we have a developer environment that we think is fairly user-friendly and a good way to get you started. We have, so now if you have questions, I want to give you resources. So if you want to get started setting up the network with the developer environment, installing it in a virtual machine or in your environment, whatever, come and talk to me. If you are past that and you start thinking about writing a contract in Rust, go and talk to Fred. He's one of our core developers and knows a lot about Rust, way more than I do. If you are thinking about potential use cases or places in your application where you need some privacy, go and talk to Ainsley and John, who essentially their full-time job is thinking about use cases. So for every use case that you can think, they're going to relate to 5 or 10 more and think about and tell you about 5 or 10 other people who are developing or thought of or working on similar use cases. And if all this is like, whoo, that was overwhelming, it's like, I'm high on Enigma now, but this sounds cool, I'm not going to do anything on this one. Go and talk to Tor and Aaron and ways of getting involved into the Enigma community. I can think of at least of a handful of ways, whether it's studying a blockchain club at the university that we can support, being members of the Enigma collective and becoming ambassadors of Enigma around the world, contributing to the documentation or coding or developing use cases for Enigma. There's a bunch of ways how you can get involved. And with that, I'll finish.